Hi, you guys. This is Mrs. Bullen here with your explanation for the two sample proportion review that was posted for homework in Canvas. And so this was the problem about the prison warden wondering if it's beneficial or harmful to give prisoners access to the internet. And so I'm assuming you already read it. We're going to jump right into the solutions here. So for the first part, we're supposed to state the parameter of interest. And that is P1 minus P2, which is the true difference in proportions of behavioral disturbances in the group who received internet access versus those who did not. And so the next thing we needed to calculate was the statistic, and that is the difference between our p hat values, which was 0.5 take away 0.7. And so we got a difference there of negative 0.2, sorry. So the third question was, part C, is does the sample provide some evidence that internet access may be either beneficial or harmful to prisoners? Explain. Yes, the group with internet access had fewer reported episodes of behavioral disturbances. So there was a difference there when we subtracted them. We didn't get 0. We did have a difference of about 20%. In this case, it doesn't matter if it was positive or negative. Just the fact that we had a difference gives us some evidence. Question D says to state the null and alternative hypotheses. So the null hypothesis is that there is no difference. The alternative is that there is a difference. And because it doesn't say that one was harmful or helpful, we just say not equal to 0, okay? And then our alpha, as stated in the problem, was 0.10. So the next part of the question says to name the test. Sorry about that. And so that was a 2 sample z-test for P1 minus P2. Then we are to check the conditions for this one. So it does tell us that both groups were randomly selected, and the random selection allows us to take our findings for the sample and generalize the findings to the population of prisoners where we took the sample from. So for all of the prisoners at this particular prison. The 10% rule, remember that if we were to have taken 200 prisoners and randomly assigned them to the two groups, we wouldn't need to check the 10%. But because we're randomly selecting from the pool, we want to make sure that we are taking fewer than 10% of the total prisoners each time so that it doesn't affect the probability of a success for the next time. So that allows us to do our sampling without replacement, without affecting the probability. So this is a little confusing because we want this one to be less than 10%. We want these ones down here to be greater than 10. And so that is our large counts condition. And whenever we're doing a hypothesis test or a significance test for a difference in proportions, our null hypothesis is that there is no difference. Okay, so when we're testing the large counts and other places that we're using the proportion, we need to use the combined proportion. So altogether, there were 120 prisoners out of 200 who had a behavioral disturbance. So that's a proportion of 0.6. And so we're going to take our N and multiply it by 0.6 and also multiply it by 0.4. N1 and N2 are the same as each other, so we don't need to write it out twice. But doing this allows us to use a normal distribution. Because each of the counts are greater than 10, then we know that the sampling distribution is approximately normal. And so we can use table A, we can use Staplett. So in this case, it meets that condition. So then we're going to look down at question number 3. And this is the do portion of it. So there's a few different ways to do this. So one way would be work it out by hand, plug it into your calculator, and then use table A to find the p-value. Remembering though, if you're using table A and you're finding this area, that we're going to double it because this is a two-sided or a two-tailed test. And so we have a probability of it being the same distance away, either above or below, based on that test statistic we get. And so we know that we're below the mean by 2.887 standard deviations. So I'm going to show you guys a little bit of the technology here, if I can find it. All right, so what I did was I went to Staplett, And so if you want to see what that looks like, I'm just saving time here with everything typed in already, but in Staplets, you would go down to a 2-sample Z test for proportions, okay? And so if you do that, this is what you get. And so what we want to look at is our 2 different groups. We had one group who received internet access. We had another group who received no internet access. And so when we're looking at that, we can't just put how many out of the total. So we put in the number of success, which was 50. We put in the number of failures because we knew it was 100. Then we had 50 remaining. And then we do the same thing with the group who received no internet access. We had 70 there, and then we would have 30 there because again, it needs to total to 100. So then you can hit begin analysis. You don't really need to look at the bar graph. You can look at that to make sure that you set it up correctly within your groups. It gives you some summary statistics here. What's important is that we're doing a 2-sample Z test for P1 minus P2. And our alternative is that it's not equal to 0. You can see there are other alternatives, greater than, less than. We want the not equal to 0. And so we're going to indicate it as a success because we want the percentage of behavioral disturbances for each of these groups. And so we get a value, a Z-score test statistic value of negative 2.887, and it already tells us the p-value here, you guys. So if I had done this a different way, if I had gone and entered all of those values into my formula, and remember that we're using p-hat combined, Stapplet already did that for you, okay? If you want to do it the old-fashioned way and plug it in, we still got the same exact test statistic here. Then if I took that value and looked at a normal distribution, because this is a standardized value, that means mean of 0 and standard deviation of 1, I'm negative 2.887 standard deviations below the mean. But because this is a 2-sided test, I'm going to choose this where it says outside of a region. And then it will give me area on both sides. And you see on our other tab, we had a p-value of 0.004. Well, if you look on this one, we got 0.0039, which if you round it to that 3rd digit there, it would be a 4. Or sorry, to the thousandths digit. Sorry, it's been a while. Okay, so let's look back at the next problem, but I just wanted you guys to know the 2 different options for technology. As you can see, this one was way simpler. It just gave us the Z-score and the p-value. This one, it required a little bit of calculation. It required plugging it in to either table A or the normal distribution, but we got the same answer. Okay, so make sure you're using your technology wisely. If you get messed up right here and aren't sure how to do it, you can always go back to doing it by hand. But the technology does help us out quite a bit here. So I'm going to switch back over to the problems that we have here. And so as you can see, I drew my little picture and I labeled the p-value. And so now we need to make a conclusion. So the question was, compare the p-value to your alpha level. Well, we're saying we can, anything that's greater than 10%, we're saying, hey, that could just happen by chance. But if it's less than 10%, we're going to suspect that something else might be going on. Okay, so because 0.004 is less than 10%, and by quite a bit, we reject the null and have convincing evidence that the proportion of behavioral disturbances is different between the 2 groups. Okay, so then if we think about what type of error could we have made, we could have made a type 1 error because we rejected the null. In the case that we made an error, even though our evidence is quite convincing, there's still a chance, right? You're telling me there's a chance. In that case that I did make an error, there would be no difference in the proportions. Oops, sorry. There would be no difference in the proportions, but we found convincing evidence that there was. So the consequence could be that the warden unnecessarily gives internet access to inmates when in fact it doesn't even affect their behavior. Okay, and then I just realized I didn't write down the answer to part C, which was, what is the probability that a type 1 error is made? And that's just our alpha level. Okay, in this case, it was 10%. Okay, so 10% of the time, you might be wrong. Okay, and that just is wherever your threshold is set for that significance level. Okay, so we're going to go ahead and move on to question number 3, which is, sorry, question number 5. Looking at the wrong page. Question number 5, which has to do with the confidence interval. And so we're using all of the same data, but remember that in a confidence interval, I'm looking at my statistic here, which is the difference in proportions. We want a 90% confidence level. So our Z-star critical value is 1.645. And then I'm not using the combined p-hat anymore. I'm using p-hat 1 and p-hat 2, and then 1 minus p-hat 1, 1 minus p-hat 2, and then I'm plugging in the n for both of those. So this is the confidence interval that I come up with. And again, I want to show you guys the different ways to do that. So let's, we'll switch back over, we'll switch back over to our technology here. So one way would be using Desmos. Type it all in, takes a little bit of time, a lot of bit of time, but you can get the right answer. And then you would do once with minus, and then you can change that and do once with plus. Another way to do it would be to look back at the same information that we entered, but instead of doing a z-test, we do a z-interval. Okay, so I have the z-interval for P1 minus P2, and then I give a confidence level of 90%. And then success is if there's a behavioral disturbance. Success. No, I'm just kidding. But that's what we're measuring, is the proportion of that. And so it tells me the lower bound and the upper bound. All I have to do is put parentheses around those and a comma in the middle, and I'm done. That's my interval. Okay, so if we went back to Desmos, could we have got the same answer? Yes. Arrived at the same answer. That 5 rounds that 1 up to a 2. If you change this to a plus, now I have that negative 0.088 value that was over here. So we got the same answer both ways, either in Desmos or in Staplet. Like I said, Staplet calculates it all for you, so you're less likely to make a little mistake as long as you understand how to set up this two-way table. Okay, so let's go ahead and here's just, if you go to Staplet, where to find it. So we're going to go down to traditional inference, and everything that we've been doing are these top 4. We've been doing some proportions, and so we did 1 sample, we did 2 sample, we did confidence intervals, we did tests. So make sure you select the right one of those. All right, we're going to go back to the problem. So as you can see here, let me zoom in a little bit more. Boop. As you can see, I copied down the numbers there, and we have our interval. And the question was, what is the margin of error? And so if I write this out, like solve this, I get the margin of error. Another way you guys can do that is find the middle between these two and see how much you went up and how much you went down. So subtract them and divide by 2. So that will tell you the margin of error. Or you could just plug this in. Either way, but I found that the margin of error was about 11%. And then question C was interpret the interval in the context of the problem. So I'm 90% confident that the interval from here to here captures the true difference in proportions of behavioral disturbances between the 2 groups of prisoners. So the question D says, this is a long problem. Question D says, does this interval support your decision from the 1 sample z-test? Remember, in our decision, we said there is convincing evidence that there's a difference there. And so does this interval confirm that? Yes, because the value 0 is not included, right? If there was no difference, it would be plausible that 0 was included if this was a negative and this was a positive, okay? Because they're both negatives, that shows us that the value of 0 is not included in the interval. So it's not one of the plausible values. Is it possible? Yes. Is it plausible, likely to happen? No, not within our 90% confidence interval. Okay, so we do have convincing evidence that the proportions are indeed different than each other, or different. There's a difference between them. Okay, and so then there's two different ways for part E. If the warden wanted to have a smaller margin of error, what are two different ways to accomplish this? Well, looking at our formula, we see that we're multiplying by Z for our margin of error. So that critical value there, if that were smaller and I were multiplying by a smaller number, then my margin of error would be smaller. So the way that we get that critical value smaller is by decreasing Z star or your confidence level. So instead of 90%, if I'm like 85% or 80%, as that goes down, the margin of error gets a little bit smaller. The more certain I want to be, I have to cast my net a little bit wider to capture that true proportion, right? If I'm okay with being like 90% confident, then I can narrow down a little bit. All right, and then the other way would be increasing the sample size, because you see that we are dividing by, I know it's like size 2 font, that's an N1 and an N2. We're dividing by the sample size. So if I divide by a larger number, that makes those values get smaller. Okay, so the two ways to get a smaller margin of error would be either decreasing the confidence level or increasing the sample size. That is it for your two proportion test review problem. So hopefully if you have any questions, send a message to your teacher. All right, have a great day. Bye.